So we'll try and get this done in time. We might move a little quick, but yeah, I think we'll be able to cover everything. So my name is Arnie Anderson. I'm director of developer advocacy at Aerospike. We're a NoSQL distributed database, do all sorts of fun stuff. And so today, I want to talk to you guys about a project that just launched. So it's actually live on aerospike.com. I've got two amazing interns in the back there that did most of the work that I'm going to take credit for today. We built a hybrid search engine. So we're going to talk about kind of looking through vector search and a inverted keyword index, using Aerospike as the storage backing, the vector database, and just kind of talk about how we did it and all of that kind of in Python, right? So we'll talk a little bit about building a better search first. I'm going to keep looking up here. And then we're going to get into semantic search, so using the vector database and kind of building out that function. Keyword search, so the inverted index, what we did there, how we worked with that data, and then kind of ranking and sorting, right? So tying all of that together into a single cohesive set of results that you get back out on aerospike.com. And then the tying things together, kind of look at the front end piece of it and how we're deploying some of the back end parts of that Python server. And then a little bit about the future of what hopefully Aerospike Search will have and look forward to. All right, so why did we want to build a search engine? That image that you guys see there, that was actually created by ChatGPT. I asked it to draw me a picture of a search engine that's not really good at searching. I think it did a pretty good job, but then it added all of those toasters. And I asked it, like, what's with the toasters? And it was like, oh, they're just nonsensical and fun. Do you want me to put something different that's nonsensical and fun in there? I said, no, toasters are good. So we stuck with it. But the real reason why I asked that is because we had a search engine that was really bad at search. It was broken. Like, you went to the website, it didn't look good, it did not work well, it couldn't filter, it couldn't really do anything. And so it was like internally, everybody just used Google, right? They go to Google, aerospike.com space, and then whatever they wanted to search for on the website. A lot of people do that. But why not give people a better search experience on our actual website? So we started looking into how we could do this, especially because we have this new vector search. And then we started looking at the kind of bigger picture. This opens the door to more complex search functionality, better ways to surface content and information to users of Aerospike. And then we are not super great at kind of eating our own dog food, right? Like, I do a lot in the developer advocacy sphere where I'm doing work with Aerospike, but internally we don't use Aerospike. So let's use Aerospike, right? Like, if we have this great database, why aren't we using it? So that was another big piece of this, and then just why not, right? Kind of a fun project to explore and learn some new stuff. So our plan, we're basically taking the entirety of aerospike.com plus this little side bit of a support knowledge base, and we're going to scrape, or we are scraping, all of that data. So we're actually using Scrapy, which is a Python library for scraping websites, works really well. And then on our server, we're going through that scraping process. We're going through kind of like a data prep process. So we'll talk a little bit about that in terms of both the semantic search and the keyword search. And then we have a fast API endpoint, so just like really a single REST endpoint for search that we're then hosting with Unicorn and then using GUnicorn to kind of do our production worker threads. So the database, we're storing everything in Aerospike. So that is our vector search, that is our key value. So the actual document information that we're surfacing back through that search. And then we are storing the inverted keyword index in there as well. So you're basically getting 3 different data models depending on what it is that you're trying to do. We're utilizing Gemini, so Google's Gemini for our embedding model. We'll talk a little bit more about that as we get to it. We didn't start there, but that's where we ended up, and it's working pretty well. And then the front end, our actual aerospike.com is an Astro website with a bunch of React components. So if you're not familiar with Astro, I would definitely check it out if you like to do front end work. And then React is just kind of really easy to integrate with. So that's kind of like the overall plan. And what we'll do as we go through here is talk about each of these individual pieces kind of on their own, right? So we'll start with the data. Aerospike.com, so the main website, the documentation, we have like a developer hub, blogging, content, all of that, and then our knowledge base, which is like a kind of separate support.aerospike.com. We're taking all of that data and scraping it. I remember having some conversations with marketing, talking about like, well, it's really easy for us to scrape the documentation, it's really easy for us to do the developer stuff, because I actually wrote those websites, so I know exactly what I need to target for scraping that. But we had an agency build the aerospike.com, and I was like, do we need to put the marketing stuff in the search? Like, does anybody really care about that? And they said yes. So we came up with some pretty interesting XPath queries to be able to target each of the individual types of content within that site. So Scrapey, like I said, is running just nightly right now. And the way that we're working with this is we effectively scrape a page. So XPath query targets a very specific like div or section within the website. So we don't want any like the ads to other areas within the Aerospike website. We don't care about that. We don't care about like what the related content is for that particular page. We just care about the core content on that page. So we're using these XPath queries to target that data, and then we take that and convert it to Markdown. So it's all just one big Markdown file, and then we hash that, and we store that hash in the database. Right? And so when we scrape every night, we take the page and we run a hash and we compare the two. And if they've changed, then we need to do the work to update the index. And if they haven't, well, then we just ignore it and we move on. And the reason that we did that is because the main website, the documentation, the developer, the blogs, the knowledge base, they all seem, well, the knowledge base not really, but the other ones all seem like one cohesive website. They're actually three totally separate websites with a whole reverse proxy that I had to build in the background to make it look like they all live on aerospike.com, but they don't. Right? So this was the easiest way to do that without like getting into GitHub and trying to pull the source material from there and all of that. So when things change, we don't really care. We just scrape the whole thing every night. But we only do the work on the things that actually change by comparing them as hashes. Now, we are using Llama Index for kind of like the data prep. And so this works on both the vector side and the keyword side. And so Llama Index is what we're utilizing for chunking of that data. Now, the reason that we're chunking up the data, so basically building smaller sections or smaller documents that make up an entire document, is because eventually this is going to turn into a RAG. Right? And we're going to want to send those like targeted small areas of relevant content over to an LLM to generate responses on how to do things. So we figured, let's just chunk everything up. Smaller data is going to be easier to work with as well. I built this whole RAG demo like 6 months ago, and I dabbled in setting up, my own chunking algorithm and played around with that, and it was just a giant headache. And so Bob in the back there came up to me one day and he was like, "Can we just use Llama Index?" It's like, okay, cool. And so he then showed me what Llama Index looked like, and it was literally, I want 512 tokens, I want them to all overlap by 32 tokens, and then it just does it for you. So that made things significantly easier. So we do have like effectively that, right? 512 token chunks of each document. And then we're basically indexing all of those as like chunks of the overall larger document. So when you get done with the scrape, the total database itself is about 6,000-ish records, and that's like all different chunks of all the documents together. There's only about maybe 2,000 total pages that we're actually scraping. All right. Now, it's a semantic search piece, right? So we've scraped our data, we've prepped our data. Now we're going to start storing this data in the database. But because we're splitting this up, we're doing a hybrid search, we need to have kind of the vector data that we're going to be working with, and we need the keyword data that we're going to be working with. So we'll start with the vector. If anybody was at my talk yesterday, we went through a whole little thing about what vectors are and building a little vector database and all that. We are just doing exactly that, right? So we're utilizing, like I said, Gemini for the vector embeddings. We'll talk more about what that gets us in a moment, but if you're not familiar with what a vector is, it's literally just a list of floats. And so it is a way for us to capture semantic meaning with a chunk of text. And then be able to query that with a different vector, right? So like a query, plain text, somebody asks a question, whatever, and we're able to find the relevant material to that. So reduces this high volume data down to just that semantic meaning, if you will. And the image that you see there, that's another ChatGPT image. And this is the second try. I thought this was real fun. The first one looked awesome, but it had a bunch of words like that weren't really words. You know how like they do that? It's just not quite a word. One of the words looked really similar to a really bad word. And I was like, I can't use that. So I said, hey, I really like this image. Could you just give it back to me with no words? And it said, sure thing. Here it is with 0 words. There's a lot more words here, but I don't see anything that looks offensive, so hopefully we're good. So we're generating vectors. We're utilizing Google's Gemini. We started actually using NumFOCUS AI, so that's a really handy embedding model. It's one that I've actually used quite extensively in other RAG applications and things like that. It's great because it utilizes this like Matrushka representation learning that allows you to go from like 768 dimension vectors all the way down to like 64 if you wanted. So you can kind of fine tune at least like data sizes, how much I want to store, and also kind of accuracy, right? Like generally, the more dimensions, potentially, the better. Obviously, there's points of diminishing returns. 768 though works really well, and what was really great is when we decided to move from NumFOCUS to Gemini, they both use 768 dimensions. So we didn't actually have to like rebuild our index or anything like that because we're just updating the flows. So Gemini is super fast. Like I said, there's like 6,000 records, if you will, or chunks of documents within there, and each one of those needs a vector generated on it to be stored in the database for search. And I ran the scrape like, I don't know, like 3 times in a row, scraping everything, right? So I hadn't yet got to the hashing and all that. I was just trying to get all the data in there and start testing things. And so we're talking, like 18,000 vectors generated, and it cost me like $2. So it's like, this is pretty great. This is cheap. So very inexpensive when you hit that API endpoint, and it was really fast. That was the other thing, is with the NumFOCUS AI, if you were, like we were actually just running it locally on the server, it's not a very heavy or large embedding model, but it did take like 500-600 milliseconds for us to generate an embedding. Whereas Gemini, we can do it in maybe 150. So it's a lot faster that way. Is there a question, Ray?
How do you relate the tokens to the embedding or the dimensions? Sorry, tokens to the chunks? And then you also said you had 502 tokens that you wanted with 32 tokens overlap. How did you know you wanted?
So that, like in the chunking process itself, it's honestly just trial and error. Like what's going to work best. The overlap piece helps to like maintain semantic meaning across chunks. Like if you look at a document, right, a lot of times there might be like a paragraph that exists within the context of the document and makes sense when it's within that document. But if you were to pull it out on its own, you'd have no idea what it's talking about, right? And so when you have that overlap, you can kind of carry the context from one chunk to the next and so on, and try and avoid some of that. But yeah, it's a lot of trial and error.
Yeah. There's one.
Oh, yeah.
Just to continue on the theme, do you have any sort of validation set or anything, or is it more just like, let me try some queries and kind of see what gives me a good feeling, or are you like, is there more like rigorous test set kind of thing?
So in a perfect world, absolutely. Like I would have a bunch of queries that like I would know exactly what I want to return and try and get to the closest point that achieves that. For us, we didn't do that. We just kind of played around with it until, and I'll be honest with you, probably like within the first like 2 or 3 iterations, we were like, holy cow, this is really good. Like we were getting amazing results just by going through, kind of some of the defaults that we had originally set. So yeah, it was, in a perfect world, there would be a bunch of that. I have a test set, and I'm getting that kind of feedback on whether or not it's actually doing what I hope it does. All right, so storing the data, obviously, right, this is aerospike.com search. Like I said, we want to eat our own dog food. So we are storing the vectors in Aerospike. So Aerospike, I said, is a key value store. So that provides the storage backing for the vector service. And the vector service is a HNSW, so that's hierarchical navigable small world. One of the very many, this is the graph flavor of the approximate nearest neighbor algorithms. That helps us to do, specifically in this, cosine similarity search across those documents, right? So we're generating vectors on queries, we're taking that kind of search vector and applying it across the entire database of our document vectors, and we're trying to find results that have the most similar angle, right? So that's what we're doing here. And so we're using Aerospike because it's Aerospike, and also it's super fast. So as you see, as we get kind of towards the end of this, we are able to achieve some pretty amazing search times because of the way that we're able to access this data incredibly quickly. Okay, all right, we're gonna move quick. We got 10 minutes. So querying the data. We're basically taking a user, I'll go point up here, but we're taking a user query, we're putting it through Gemini's embedding model, we're then taking that, searching the database, we get the documents, now they come back as a sorted set, right? So we know the order in which they come is going to be the closest as at the top, and then as we get lower and lower, we won't really care. So we also have a threshold set there. So if you don't set a threshold and you tell it hey, go search the whole set, you type in gibberish, it'll find something, right? Because there's some vector that is at least some variation of an angle away from that. So we've just kind of set a threshold, what's acceptable. Anything below that threshold is no longer, or it's really above that threshold is no longer anything we care about. Yeah.
Sorry, you set a threshold in cosine distance.
Yeah, exactly. So basically, we get, with Aerospike, even though we're doing cosine similarity, we get what's called a distance back, which you would generally put with the Euclidean distance. But yeah, so we're taking that threshold, the distance score, and we've just set a value that says, if this is, not within this range, forget about it.
With it basically, you said for trial and error experience.
Yeah, 100% trial and error. Yeah, basically, when do I stop getting garbage? That was it. All right, so the keyword search. We're using an inverted index. This was another ChatGPT image, and it was right out of the gate perfect. I saw this, and I was like, that's it. You did it. And then it even explained to me what an inverted index is. So that was pretty cool. But if you're not familiar with what an inverted index is, this is something very commonly used in search engines. Basically, you're flipping things. So instead of searching documents for keywords, we're searching keywords for documents, right? So every keyword that we have within this is going to basically maintain a list of all of the documents that have this keyword, and then within that document with the keyword, where it shows up and how often it shows up, right? So frequency and position. And then we have some other metadata and stuff in there as well. So for this, we're utilizing Spacey. So this is a natural language processing library that does some really cool stuff with tokenization, stop word removal, and lemmatization. So getting to like the base root word so that like we don't have just a million keywords, right? Everything is kind of fit into these sort of base root word examples. So each of the chunks, just like they go through our Gemini for embedding, they go through Spacey to create the tokens and the keywords that we're going to utilize. And then, like I said, each of those keywords becomes a record in Aerospike. And then that record is a map, right? Really a dictionary, where each key is the document, and then each value for the document is just a list of position, frequency, all that kind of stuff, and some other metadata that we have out there. And then well, yeah, this is it. I just went through the whole thing, but this is that key value piece. Again, keyword becomes record, storing the data. Now, when we query this data, we're going to do the same thing that we're doing with our vector, right? So we take the query, we put it through Spacey, we get the tokens from that query, and then we grab all of the records that come back from that, and then we need to send them back to you, right? So we have a list of all the documents that contain these keywords, but like, which ones are the most relevant, right? Which ones like have the keyword that shows up more often than others, or like has that keyword in proximity to other keywords, and so on and so forth. So we needed a way to kind of order these. So we're using math, right? So BM25 or best match 25. I won't go through this whole thing with you for time and because I'm not very smart, but basically this is a way for us to take all of the retrievers, or excuse me, all of the queries. I'm getting ahead of myself here. We're taking the inverse document frequency, which is basically like, how important is this keyword within this document compared to across the entire set of documents, right? So how frequently does this show up? And then you're looking at like the frequency of each query keyword within the whole set of documents, and so on and so forth. It's all labeled there for you. Yeah, fun. That was a vibe auditory thing. They're the real ones back there. Now, we need to rank and sort all of this stuff together. I have two searches. We're doing these in parallel, right? So when you do a search, all of that stuff that's happening on the vector side is happening while all of that keyword stuff is happening as well. So you get two results back, and now we have to put them together. There's going to be duplicates in there, and there might not be some, and so on and so forth. So we have to figure out how we're going to put all of that together. So we went to semantic re-ranking. And we used Gemini, and it was fast and cheap, but it destroyed our results. We would look at our vector results and be like, this is amazing. We'd look at our keyword results and be like, this is awesome. And then we'd look at the two of them together after semantic re-ranking for Google, and we'd be like, this is terrible. This sucks. So we went to Cohere. Cohere gave us pretty good results, but it was kind of slow. It added like 500 milliseconds to every query, and then it cost money, right? We have Google credits. So like Google's fun to use and easy to use because we have credits. Cohere, we don't. So we decided maybe let's try for another option, right? Is there a better way to do this? Enter reciprocal rank fusion. More math, right? So this is super fast because all we're doing is we're using this reciprocal rank fusion function here to basically take the rank of every document within its own retriever, right? So the rank of the vector documents and the rank of the keyword documents, and then we kind of weight those scores, and then we take those scores and we are able to create like a kind of normalized score throughout all of those, and then rank them with that singular score. So this actually gives us amazing results. So we were able to see like the really good vector results and the really good keyword results coming through in the actual final results, and it added like almost zero overhead. So very, very fast search. What's that? 5 minutes, okay. All right, I'm going fast. All right, so the server and our API, right? How we're tying all this together. So the whole backend is Python. So we're using fast API. Like I said, Unicorn is kind of like that, the server piece running back there, and then Unicorn is actually managing worker threads for that. So like we have like 4 worker threads that it's just monitoring and spinning up, and if somebody breaks the server, that just resets, and it's really nice in production. So very fast to develop with. I'm a big fan of Fast API. If you haven't used it, I'm sure you probably all use it. It's huge, right? But it's super easy to work with, and then we get amazing performance out of this. So like every search that we run, we're averaging roughly 80-ish milliseconds, which is pretty solid. Like I said, the front end built in Astro using React, and then oh no, I'm on a free meeting. I thought I was in my work account. That's fine, we're good. So the website, like I said, Astro and React. This just gives us a really nice, kind of easy to use, interactive space. And so the way that we put this together, pull this up here. Let me just exit this. There we go. The way that we put this together here, on the home page or really any page, you can launch the search, and it just kind of pops up on your screen. It's a modal. We can search something like secondary index. And again, super fast results. And the goal of this was to give you like the top 5, right? And just say like, you should probably get exactly what you're looking for in these first 5 results, so you never have to leave this page. But then, if I want, I can see all the results. And then on that page, I have the ability to do like filtering down to a very specific type of documents, so developer documents, or potentially blogs, or any combination of those in between. And it's just a much better search experience. Pagination, filtering, all of that is happening on the fly. And because we're able to have all of that super fast search, we're actually running the search every time you do something on here. So every single time you paginate, you're going and searching all of that data again, because vectors are really hard to paginate. So you're getting all of that, and then we're just giving you the page that you happen to be on. But because the search is so quick and efficient, it doesn't really feel noticeable, right? Like I can move and it just feels like it's all in real time, because we're a real-time database. So yeah, that is our hybrid search. I feel like I have one more slide here. Yeah, the future. This is my favorite one. So this was another ChatGPT image. And that was, I asked it like, draw me a world where search has become so good that everything is just perfect now. And this is what it came up with. And then it gave me that a perfect world where improved search has transformed daily life. People enjoy seamless access to information and harmonious, futuristic aesthetic, right? That was supposed to be a joke. Now we'll probably just build a rag, but that's kind of the future, right? That's what we're looking forward to. Easier access to content on aerospec.com. We want people to be able to go there and feel connected to our content, right? Our documentation, be able to search it, be able to surface new and interesting things and learn. So, yeah. I will just throw this up here real fast as well. I'm going to throw these slides like in the sharing thing on the schedule as well, so you guys will have a copy of these. But please feel free to join the Aerospike Discord community if you want to know more about Aerospike. We're also upstairs. We have a booth. And then our vector database, we're using this in production right now on aerospike.com, but this is still kind of like a beta. So you can scan that QR code, sign up for a free trial, spin up a little cloud instance of all of this, and you can start playing around with it yourself. We'd love to hear your feedback, so please go ahead and give that a shot. And yeah, thank you very much.
am Isabel Zimmerman. I am a software engineer on the Positron team. You're probably in this room because you're like, what is this Positron IDE? That's the name of the talk. Out of curiosity, who has heard of the Positron IDE before? Oh, that is so much more than I was expecting. Welcome. And if you don't know anything about the Positron IDE, this is the best room to be in. I work on the Python experience. That means I write Python code. I think about things like, how does the autocomplete look the best for data scientists in Positron? Or even things like, what UI elements will data scientists need? And this is really important to me because I started out learning data science in a classroom. And in this little class, it was called Intro to Data Science. I had a fantastic professor, Dr. Sanchez, and he taught me about this cycle. And this cycle was tidying data. You import it, you transform it, you visualize it, you model it, and you communicate it with others. Many people who are data scientists, this seems pretty familiar. Full warning, I was writing all R code. The first day in this class felt super magical. I was in this RStudio IDE, and it's got a lot of different UI elements to really help you have a super seamless experience. I did not know anything about programming at the time. I made my very first plot that was not in Excel in RStudio, and I was able to do this all the first day. There was in IDE help. It just felt like I was very supported all the way along this data science experience. And I went on to do more schooling, more learning, more classes, and RStudio was an IDE that grew with me. And I finished my degrees and I took a job doing not R work, and I realized that this data science life cycle is the same. It doesn't matter what language you're writing it in. Some of you might have the same experience of learning a different language and then transferring it into what you do now. And a lot of those fundamentals stay the same, but something that did change were the tools that I was using. I was no longer in RStudio IDE. I used Jupyter Notebook, like just that classic notebook experience. And I ended up in Jupyter Lab, and I ended up in Visual Studio. And it felt good for a lot of reasons. I was using a lot of Jupyter Notebooks, and that's what these are made for. But it felt like something was missing. Some tasks sort of felt like I was stubbing my toe on the corner of a table when I was navigating through this IDE. And of course, stubbing your toe is not going to ruin your day until you're stubbing your toe 8 hours a day, 5 days a week. I really wasn't able to find an IDE that maximized this data science experience. I do a lot of iterative work. What about, tracking all the commands that I run, all of these things. So I guess a few years later, now I have hobbled my bruised feet over to working on the Positron IDE. And I'm hoping I can convince you all that this will give you a little bit of joy and maybe minimize some of the pain you feel with other IDEs. Okay, so here's the question. What is Positron, and how does it support data scientists? It's important to think about not only my origin story, that's not really important here, but maybe the origin story of this IDE overall. So it is a multi-language IDE for data science. Positron is a fork of the open source VS Code, and it is customized for data science. This is a really classic move that other IDEs have taken. If you've heard of Cursor, it's an IDE that's been forked and then used, really specialized for AI. It's really great because you're able to use OpenVSX extensions. It's pretty familiar for people if you've used VS Code before. It enables multilingual data science. You get to build off of this community. But perhaps the most importantly for what we're building is that it is a strong IDE base that we are able to customize to help do a little bit of interior decorating for data scientists. And that's because data science is a very iterative process. You want to do your quick experimentation, you're writing code, you're refitting models. You want something that's going to support this. And it's important that this is made by Posit as well. If you're not familiar with this name, you might know us by our prior name, RStudio. That maybe was a bit of a leading story earlier. But what that means that we have built RStudio is that we have decades of knowledge of specialized IDEs specifically for data science tasks, which we know don't change depending on the language. So it made sense for us to branch out into this multi-language IDE. We've been building Python tools for a long time. We've built tools that support Julia and other data science languages. So it felt right to share the joys, the interior decorating changes that we've made in our studio with the wider community. So this is your first look at Positron. And it's kind of a lot in this screenshot, I'm not gonna lie. So we'll break it down step by step. If you look at the very top, this is kind of your where and what are you working on. So you can see here, there's like your little search pane. You might have to like zoom in, I don't know if you can actually zoom in, but there's a little search pane up top. There's the way that you can tell what interpreter you're using. You can see what directory you're in. The classic, who, what, when, where, why, how of an IDE. And of course, there's also the place for your source code. So this is another classic, you need to be able to write code somewhere. This is kind of the pane of the IDE that does that. And right below it is a console. And this is your sandbox for your code. It's interactive, it's fully featured. We'll dive into it a little bit more later, but you can kind of think of it as a playground for code. And then the entire right-hand side, you can of course resize these if this looks like it's taking up too much space or whatever, is context about your code. So this is telling you more about the variables you've created, displaying the plots you've designed, it's going to render the documents you've written, and a lot more. So Posit really believes in the magic, the beauty, the reproducibility, all the reasons that people believe in and want to support code-first data science. We think this is the right choice for science, is to have code that's portable, that's reproducible. But sometimes a little bit of UI elements helps to make that writing code experience more helpful to the people who are writing the code. And the code that you're writing is going to go over these tasks. For this talk, I'm going to step through each of these data science tasks. And at Posit, we're trying to kind of form, what questions are data scientists thinking about each step of the way, and how can we make sure that they feel fully supported throughout the entire end-to-end data science process. So of course, we start with importing, go on. But maybe the elephant in the Python community room is that the beginning of data science looks sort of like this if you're writing Python code. And this is a XKCD comic that is really highlighting all of the many, many beautiful and somewhat successful ways you can install Python onto your machine. And if you think this is confusing, wait until you get into creating a virtual environment, all of the tens of tools to do that, and activating it, and making sure it's active in the terminal you're using, and making sure that's actually the Python script. It's a mess. It's a mess, it can be confusing. And that was kind of the first place that we thought, maybe a little bit of UI would help people here. So in that who, what, when, where, how, why, all your W and H questions bar at the top, there is an interpreter selector. So you can see on your screen, I'm going to keep pointing to this, your screen, that at the very top, Positron will sniff out kind of all the different ways that you have Python installed, all of the different environments that are available. There's Conda, there's Mamba, there's PyEnd, there's Zend, there's VirtualEnd, there's Poetry as well. And it can be hard to wrangle these and make sure that they're all activated the same way. In Positron, you can kind of go through this UI experience, and you can tell which one is active in your IDE by a little green button. It's also the one that's on the top. If you want to turn it off, you can click the power button. You can refresh your kernel right there, turn it back on, and this will activate your Python, whichever one you've selected, in the terminal, in your console, in all your Jupyter notebooks. You're also able to switch it, of course, but to have that unified experience where you know what Python is running at any point in time, which is sometimes a harder question than you would like to admit. So this is kind of the first step in Positron. For people who are new, go to this website. For other people in the room, we are now part of this community together, and if you can tell people who walk in and sit next to you, you just point to that link. We will all have the slides, because there's no projector here. Okay, so once you have Python chosen, you want to use this interactive console to maybe experiment with your code a little bit. And so this is a live IPython console. It's a good place to test out code quickly and see results. It is sort of a playground. It's nice as a sort of in-between between a Jupyter notebook and writing a Python script. So if you want to just quickly run pieces of a Python script, you can do Command Enter in your editor, and it will automatically send this to the console, which has been super fun for me. I also manage and maintain some Python libraries, and so being able to just like quickly run through that code, making sure it still works. Before, I really copied and pasted a lot of things into a Jupyter notebook and then brought it back for development purposes. So having this console at my fingertips has really been a life changer for me. So I use Positron as a Python package maintainer. I use Positron for building demos. I use Positron to build Positron. There's some inception level things happening there. And a lot of that is because of the usefulness of this console. You can use this Command Enter to run your code there. It's fully featured. It's connected to other pieces of the IDE. We'll see a few other ways that you can visualize context about your code. And it's connected to all of those. It has autocomplete. It has syntax highlighting. All of the things that you would expect are fully featured in this console. OK, so we haven't even started our data science process yet, but we're running Python now, and that feels good. And we're able to switch Python environments, and that feels good. So we'll start by importing our data. And some questions that people might be asking at this import stage is, how am I getting data into this project? And it's probably starting at a database. So if you have connected to a database by running some Python code that creates a cursor object in SQL Alchemy, if you're familiar with that, or some sort of database connection, there's a pane on that right-hand side, and this will show up. So you can see here, it will get all of the tables for your database, and it will show you all of the rows and the types of the rows, or types of the columns in the database tables as well. And this is really helpful. If you click on that little eye, the data in that database table will automatically populate. You don't have to run any code. It's one of those places where code-first data science is useful for the reproducibility part, but sometimes there's some rough edges. You just want to take a quick look at something. And this is a nice place to kind of ease that transition. Not only can you view your database information here, you can also manage your connection. So you can refresh a connection, you can disconnect. If you want to disconnect from your database, it can also reconnect. It will store the knowledge of how to manage this database connection. And it's currently supported for SQLite. If you have other ideas, we would love to hear from you on GitHub. So we have data in hand.
There's a question.
Yes.
Sorry, I don't want to interrupt your flow.
Can we do questions at the end?
Yeah, that's fine.
Perfect. All right. So we have data. We will now tidy it. This is a hard, very overwhelming question. And it kind of starts with, what does my data even look like to start? What are the columns? What are some summary statistics? Can I quickly open all of these files of data that I have on my computer? And the answer is yes. So this is built into Positron. This is our data explorer. If you click on a polars or pandas data frame, or if you open it up from the variables pane, which you'll see shortly, you get this beautifully full-featured data explorer. It has things like summary statistics. It has the little spark lines for your data. You can sort of like debug your data by quickly scrolling through it. And this is a data explorer that's highly performant. We've had tests with tens of millions of rows and millions of columns, and it acts pretty much the same as if you had like 30 rows. It's kind of magic how it works, and I'm always impressed by how large of data sets people are using in this data explorer. And something that's new, and I think just the most beautiful thing I've ever seen, is you can also click on CSV or Parquet files, and they automatically open in your data explorer. You don't need to be running Python, you don't need to be running R, you don't need to be running Julia, because this is using DuckDB with WebAssembly code to automatically load it, so it's very fast. And I mean, how many times have people tried to open a Parquet file, and then you have to think about time to go to Python, time to click all these boilerplate buttons. It seems simple, but I feel like this is so magical to be able to just see your data so easily. So this is new. Our Data Explorer is something we're super proud of and is continuing to transform. So next is transform, visualize, and model. And this is where you're sort of delving deeper into this experimental data science lifecycle. Here you're asking questions like, what was that variable I created again? What are the parameters of that model? And how can I quickly look at all the plots I created? So the first part of this is thinking about your variables. We have a variables pane on this right-hand side again. It has the name of all the variables you've created. If there's other context, you can expand them, like you can see all the different rows in your data frame. There's some helpful context to help you remember either what the value is or other information about your variable. And then on the farthest right side, you can either click on this little table icon to automatically open into that Data Explorer. You can click on the little database cylinder icon, and that will automatically open your connections pane and connect to your database. It's super handy when you're moving between different notebooks. There's different tabs for different notebooks. And I think it's just kind of a nice way to like refresh what's been happening in your code. If you're in a console or in a Jupyter notebook, if you write anything, pretty much anything, and put a question mark after it, we also have a help pane. So you can see we did pd.dataframe question mark, what's happening with this data frame. And we have a rendered help pane built into the Positron IDE. This is something we're also super excited about, being able to have at your fingertips, like a beautifully rendered doc string is very powerful rather than going out to the internet or trying to like scroll through RST or something like that. This is something I also use as a package developer a lot to really make sure that people can navigate through my docs efficiently. So if you see on this screenshot, things are interlinked natively. So if you click from data frame from records, you can navigate to that page instead. There's also examples that have a little copy button that you can run on the console. We support NumPy, space-style doc strings, as well as Google and ePy or EpiText, depending on how you're supposed to pronounce that. There's also plots panes. So this is another place where we believe that data visualization is a very large part of data science. And so we had a dedicated space for this. And this is important because if you're iterating on a plot, like here, sometimes you're writing your subplots and you're adding things onto this data visualization, and it will update as you go. But of course, not all of our plots are perfect. We're not ChatGPT. And this comes in handy when you have a lot of plots. You kind of get this thumbnail experience. And you can see the different iterations. You're able to resize them. You're able to export them as PDF or PNG or TIFF or SVG or a number of different ways. And one of my favorite buttons in Positron, just as a whole, is there's a copy to clipboard button, because we all know that plots always end up being exported into a Word document. The final step of our data science experience is communicating. And we have a viewer pane, again on this right-hand side, to view your locally running content. It's fully interactive, and it is right in this IDE. So you can view localhost URLs. Again, we're in New York. I thought Wordle seemed like an appropriate thing to be showing in this viewer pane. This is a Streamlit app. And if you are running Streamlit apps, Panel, Radio, Shiny, Fast API, or Flask, that little play button in the top corner is going to be running this app in your terminal and automatically opening it up in the viewer pane. So you don't have to write the same command over and over again. You can just click your button, and it will automatically populate in this viewer pane. I also had to add a little bit of slideception here. I developed these slides in Positron. They are all Markdown. And so here was me in a non-purple background version of my slides. In Positron, as I was updating them, I would just save. It automatically re-rendered in this viewer pane. And it was really just, like, it's a delightful experience. I get to put my slides on GitHub afterwards. It feels great for me to have this portfolio of slides. I'm just a big Porto fan. I think it's great. And this viewer pane really helps me to be able to develop things quickly. So this is what Positron looks like. This has been a very fast walkthrough. It is super fun to play around with. We tried to make it intuitive for people. It should feel friendly to people. You should be able to kind of download it, and Python should be running as long as it's on your machine. And it's something we've been really proud of at Posit, and we hope that people will try it out. So what else is happening with Positron? Up next is going to be updating the Jupyter Notebook experience. We think that there's a lot of UI elements that can be adjusted to make things a little bit easier to maybe connect to kernels or go through code in a Jupyter Notebook. I do have to say, Positron is an early stage project. We have just released it to the public as of 3 or 4 months ago, whenever August was. But it's ready for real work. We spent a lot of time on it. We have a lot of miles on it. But if there are some weird things happening, feel free to visit us on GitHub. That is where it is available. You can download it from GitHub. If you want a step-by-step of how to download it and get started, it's available at positron.posit.co. It will take you through the whole process. And thank you.